Hello. Yo, Adam, are you here? I'm doing really good. Today is Wednesday. Dev Wednesday here at the Blockchain Center. Yo, Adam, it's been a minute since you've been on here. What's up? Yeah, what were we talking about specifically? Say again? Yeah, so I was reading a lot of interesting articles on the internet, and the Associated Press actually was reporting the different sections of voting on Ethereum and EOS, and that's what I really wanted to cover today because I thought it'd be timely and it gives us a chance to talk about the platform that it was on. It was called Everpedia. We are not sponsored by them. We are just find their technology interesting enough to cover it. hmm so where here is let's see where we're at here. I was reading an article. Let's see. Let me try to bring it up. Do you see my screen? Let's see if we can make it better. Nice. So I was reading through, and it's like, okay, after major news agency, the Associated Press declared, blah blah, we bringing verified election results to the blockchain. Those results have now been officially written on ETH and EOS, and it made me be like, whoa, what is Everpedia? Let's see. Have you ever heard of this? Sure. So I guess that the idea is that it's a kind of like it's almost like a Wikipedia, but somehow on the blockchain. It seems a bit like a lot of information to be on the blockchain, but it looks really interesting. They have a lot of cool ideas, but they came in and let's see, where was it? Okay, yes, here we go. The Associated Press Election Mission Control. So we're viewing the EOS mainnet. Click here to see the Ethereum mainnet, but basically it was a really interesting quick app that they wrote to call out and secure each state and what they did. So you can see here that we have like a payload of information here, which is really interesting. What's your experience? What's your thought process on when you hear like voting on the blockchain? Skeptic? You're a skeptic when you hear it? Okay. I'm not sure about raising money here. I think that what this is I think it was just like an Associated Press article. And what's interesting is that the, mhm. Mhm. Okay. Yeah. Yeah, I mean that is type of the like that's kind of why I wanted to cover it. I was like, okay, what exactly did they do? So we can see we have not just the presidential election results, but you can see the U.S. House. We have Senate results here, which is interesting, which is really cool. So you see, like, we have Arizona, California, and actually, from what I understand, if we go to, actually, I initially found it because I saw this Forbes article on it, how to track the official results on Ethereum and EOS. Michael Del Castillo, Forbes, blah blah. He's like, okay, how does this actually like tie in? Let's see. It's like, first, software developers at various news services can build their own mobile app for viewing the results, and I think that's what we're going to try to do today. And we're going to fork off of an app that they created. So you can see that here. Let's see. Yeah, so this is their mission control, and today we're going to go over how to actually query these results as if you were trying to build an app on top of this. And interesting enough, that the Oracle is provided by Chainlink. So when you actually, yeah. So when we actually go underneath the hood, let's see. Let's go. What's the problem? There's no problem. Excuse you. Let's see. All right, here we go. So we're going to see here, this is their LinkedIn here for the Everpedia Associated Press. Let's try to load this a bit. Let's see. So we got some contracts. Can you see my screen? All right. How about now? Let's see, fetch presidentials.sol. Interesting. So I think that's what we're going to be live coding today. Let's see. Let's try to bring up our remix. Let's try to bring up remix here. Oh, right. Okay. Yeah, what is your experience with it? Do you like, yeah? Okay. All right, so let's just make a new file here. Solidity. I want to compile it. I want to make a new file. Let's do a new file. And we'll call this fetch election results.sol. Okay. So what we're going to do is that we're going to say pragma. Let me make this a little bit bigger for everybody so we can see. Can you see that? Noise. Let's see. We're gonna say that we're gonna version 0.06. Cool. We have our handy dandy. Let's see, we'll try to make this smaller. I'm gonna say we have Everpedia, that what we just looked at. Let's see. Where is the AP result? Let's see. So we're going to say master Ethereum contracts, and we're going to be importing right here testnetconsumer.sol. We're going to see that right here. So what's really nice about Remix is that you can do these imports directly from GitHub, which is, I think I've shown maybe beforehand how to mint on ERC20 fairly quickly, and it's via this. It's really nice. Maybe to ask Justin why we're not going live to YouTube. Yeah, interesting. Interesting. Perhaps we can restream it when we go back. All right. So let's do a thing. Let's do a thing called contract fetch presidential winners. Why does it do that? Fetch president. Shout out to everybody who just joined the stream. I'm here with Adam Manka. We're writing a Solidity smart contract to fetch the Associated Press election results for not just for the President of the United States, but also the House and Senate. Very interesting, huh? Let's check this out. So we have contract. It's interesting that we call it a smart contract, even though this is not like where you would say like, oh, I am going to have some sort of payment, but actually just storing something or launching these contracts. You'll be able to, we call it a contract no matter what, just to disambiguize the syntax here. Let's see. We're going to make a struct. We're going to call it winner. And we're going to make a string winner. We're going to say we're going to have an unsigned integer of length 256. Call it result now. And we'll have another unsigned integer. And we'll call it the actual block that it came in on. Cool so far? All right. So we'll say a testnet, and we'll make a consumer, and make an internal, and we'll say winners. Now, whenever we instantiate this contract, we are going to form a constructor. So every time that it's run, we can actually yeah. I don't believe it has to do with scope. I believe it has to do with internal and external, mean that if you had an external, for instance, that it would be a call made exterior to the, I guess the contract. So scope, kind of, but I guess like the context is. Okay, so public and private is kind of similar in the sense that public would be the scope everywhere within inside of, like, I guess the virtual machine of this. This would be like the actual Ethereum virtual machine, and then having a function that could be called from the non-owner or from something that was inside of this. So now this is an internal call. Yes. Okay, so we're going to construct because then we were going to talk about this constructor, and we're going to actually have a public scope for everything inside of this this contract. And I believe we're going to go to the Coven testnet. Let's see. We'll talk about Coven testnet. No. Let's see. Winners, we'll say is equal to AT testnet consumer. And we'll pull it right off of their see, for those following at home, this is actually when they publish it. Let's see, I believe it is posted here. Yeah, inside their development objects, if we're going inside here to fetch the calls, you'll see that there is a Covan testnet consumer. So you'll find that OX12B ending in 856 is where it's deployed on Covan. Let's see. Can I make sure that I'm on Covan inside my MetaMask? Whoa. I hope it doesn't reset. No! Okay, good. Great. I thought it was going forever. I'm like my head's in the way. I don't want that to be there, but I also want you to see the code. It looks like my dumb head in the way. Can you still read it? Okay, so let's write it. I think that really all we're going to do today is write one function here. And that is, we're going to write a function. I can't type today. Function select winner. We're going to accept a string. Actual state. We're going to make this public. View returns. And just what we did before, we kind of like created like the actual winner structure up there. Let's say string memory winner. We're going to say an unsigned integer of 256 to result now. I'm going to use uint 256 of the actual block that is the result in. String winner, and we're going to say another unsigned 22. So we're going to just reinforce that this is the structure that we're working with. Let's see, result now. I wonder where Justin was. Justin said he wanted to be a part of the stream too, but I think he's on a call. Are you doing it on yours too? Nice. Get the winner. Result now. Result block. Whoa. You can see with my big fat head in the way. It's fine. It's like, so we can see here, let's see. We got a constructor private, constructor public, Coven testnet, winners equal to AT testnet. You can see that we have the actual, I think, Adam, you only see my green screen, but I'm pointing directly at the address here. Yeah. And then we got function select winner. And then we're really taking the structure that we've made up here and we're plugging it in here. Because this is real life, and I'm pointing to something in real life. Okay. What's up? Let's try to lint this just a little bit. Maybe not. I don't know if this will compile, but we'll try to test it out. It may not be for here. Let's check it out. I think that it's not space sensitive. Let's see if it's actually sensitive to this. All right, so we're live. We'll see if we can actually compile it. Cross your fingers. Ready? Ooh. I'm expecting. I think we're just missing that semicolon. Right there. How about that? Oh, no, I don't think it likes that. I'm going to take it back. It's not readable nor linted. Let's try it again. Okay, what's the problem here? Expected blank, but got a blank. Uh-oh. Yes, I think that I keep on missing these. Oh. 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 Incorrect, Eric. Let's see. Blah, 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 blah. Oh, it's a unint. We don't want to unint. There you go. Uint. Nice. And do it live. Where? Oh boy. Let's just copy this. I think I just got it wrong and I just kept on doing it wrong. Tight. Uh-oh. Shattered declaration, blah, blah. Did I? Let me try to get those errors in big. Browser result, SPX selected as an identifier not provided in the license. Yeah, no. think that was because we're accepting it from this other contract. Aha! I think there's a bunch of warnings, but it compiled. What's the warning? The shadowed token. Say again? These are more warnings. SPDX license identifier not provided in source file. Before publishing, consider adding a comment containing SPDX license identifier. Definitely not, but thanks. Oh, wow. Oh, won't let me compile with all these? It's still yelling at me. I'm trying to find that out right now. Let's see. Compilation details. Let's look at this real quick. Language solidity, great. Output. Actually, it did. Nice. Oh, cool. Let's deploy it. I'm not going to deploy it to testnet. Let's just deploy it within our virtual machine here. Cool. So on select winner, well, let's see. We already have it deployed. So if we're talking about cooking show style, ready? Let's try to go cooking show style. Yeah. Yeah, so reviewing on Coven now, you can see that this would be the winners here. So you can see that result now for the U.S. for this is not real election data for developer testing only. So you can see that we're bringing the if when you actually did call that, then you'd be able to see the winner of that state. And let's look at the mainnet here. So when you actually give that call, you can see that the result now and the result block will be returned and how they inscribe that. So we got Michigan, Arizona, Iowa, so that you can see which one was called for each and at what block, which is kind of cool. And as it's really cool, and then you can know like for sure and have like, for instance, if we're talking about South Carolina, this is when it happened. Like the now is in the Unix time. So if we're gonna say, let's say copy this, let's say Unix time to date. So if we were to do an epoch converter, let's see, enter a timestamp, let's paste that in and convert it. So you can actually see this was at this time, November 4th at 2:30 a.m. That, yes. Yes. So we can get all these different ISO 8601, RFC 822, blah, blah. But we can see that it's always November the 4th. second since January 1st, 1970. So there's a lot of seconds. Well, well before my time. But that's super important for us. Cool. Welcome to Unix. Every time the world started when Unix started. Yeah, sure. Hmm. Which in this case is the Associated Press. I thought it was the opposite. Do you really think so? Yeah, but how does that differentiate between the Associated Press? Because we're not talking about we're not talking about machinery here. We're talking about an actual newspaper. Hmm. Well, there's two blockchains here in that case. We're looking at two different ones. So we're looking at EOS and we're looking at Ethereum. So we're not just talking about one chain. We're actually talking about two chains verifying the data. So, mhm. So it's kind of like, yes, you do have like a centralized source, but then you have it broadcast because at any moment you have to have some semblance of like, it's just like cryptography. Like when does your information become encrypted and when does it become secure when it actually lands on the person who's doing it, you know? Well, that's because it doesn't exist in the real world. Here we go. This is the Ether scan of it. Let's see. Let's see. I was talking about this is the actual deployed contract. And let's look at not just the contract. So we actually can see this is the Oracle that we're using here. Chainlink client, the request interface. So we actually can gain. Actually, here we go. This is something that we covered before. Is that it's for ENS. They have like a new owner transfer. Let's look at this for a second. This is actually quite chained together. No, I don't think that. I think that when we're using an interface to the wallet, so you can transfer it. But let's see. So you can see that we have like a Chainlink request interface and cancel request. Let's see. So you can see that if you really wanted to delve into it, let's check it out. Chainlink request. Actually, I wanted the reason why I'm here is because I wanted to see actually how costly it was for each of these calls. I think I found it earlier. Analytics. Transaction fees. There it is. So this is a new feature on Etherscan. We can see, yeah. Let's see. Fees. What is it? What's 0.1? What's 0.2 of an Ethereum? Ooh. Yeah, so it's not query to post, to sign it. Yeah. So actually you can see that each time that this was created, you can see this is all of the things. You can see every time that it was spent, you can see that the most of the fees spent. Actually not so bad. You can see it's like around $100 worth of all of the data that was spent for all the fees. Not too bad for something that may or may not have a lot riding on it. Total fees spent as a sensor. It's not super bad if you were talking. Yeah, it doesn't look. Yeah, I don't think that if we made those rights, if we actually wrote every time that it came in, then it would be bad. But it looks like it was like only written a couple of times. You can see here, it was written one time for that amount. So if you had a consistent like WebSocket or a consistent GET request, that actually would be crazy expensive. But that's great. Yeah, I think Etherscan just added this. That was really cool. Just like, being able to see the transaction fees adjusted for when it happened to right now. That's cool. But hey, Adam, I really thank you for coming on the show, doing some live coding and talking about the election and Ethereum, EOS in general, and Everpedia. Shout out to them. Really cool stuff. Thanks for making the app. And this is, that'd be great. Mm-hmm. For sure. Thanks, Adam. And thanks, everyone watching. This is Dev Wednesday. Thanks for coming out.